Through a couple decades of work comparing turtles on the main stem Trinity River and South Fork Trinity River, we found that the females, well actually males and females on the main stem were of smaller body size, and this difference in body size seems to be increasing over time, such that the more recent data sets show the turtles are even smaller. So we have some kind of decreasing trend in overall body size. We wondered if this was attributable to a lack of resources, but when we took a closer look at the turtles, we found they had really high body condition on the main stem, potentially indicating to us that it wasn't a lack of resources available to the turtles, but rather a reallocation of those resources to storage of lipids rather than allocating those resources to growth. We also, in support of that, noticed that the females had a lower reproductive rate on the main stem, further indicating that they were not allocating resources towards growth or reproduction. We decided to look a little bit deeper, and we took some blood samples from turtles on the main stem and South Fork and sent those off for analysis of corticosteroids, which is an indicator of chronic stress. And we found that the turtles on the free-flowing South Fork Trinity River showed a very stable pattern, where the turtles from the dammed main stem had clear indication of chronic stress, which we attributed to cold stress. We wanted to get a little bit more data to support this. We put temperature data loggers on a dozen turtles on each river, and we compared the amount of time that those turtles spent throughout the summer, the amount of time they spent basking. And we found that the turtles on the main stem were basking significantly more than turtles on the South Fork, yet they were still not reaching the same overall existence temperature. Again, showing that they're trying to compensate for this colder water, but still just not quite getting there. Hence, them probably looking towards allocating those resources towards lipid storage to be prepared for even potentially leaner times ahead. And this is just one way that they can try to help compensate for the colder water. But we do think that there could be long-term implications for population structure if this continues for a long time. But because these turtles have a reproductive lifespan that can exceed 60 years, possibly much more, we're not really sure how long, but we know at least beyond 60 years, females can still be carrying viable eggs. So population level effects could take decades to become apparent. So I think right now we're just seeing the beginning of a problem that could emerge. And this gives us one other piece of information that we can use to try to inform river management and think about thermal regimes for a functional ecosystem.